Chapter 7, Lesson 6, Slope and Similar Triangles. You will be able to relate the slope of a line to similar triangles. In the figure shown, triangle ABC and triangle BDE are sloped triangles. Sloped triangles are similar. You can use the properties of similar triangles to show the ratio of rise to the run for each triangle are equal. What makes these triangles sloped triangles? Well, they are triangles formed to help find the slope of a line. Write a proportion comparing the rise to the run for each of the similar slope triangles shown above, then find the numeric value. So if we look here, the rise over run for this red triangle would be AC over BC. And the rise over run on the green triangle would be BE to DE. Now find the numeric value. So we have to count here. We have 1, 2, 3, 4, 5, 6 is the length here. 3 is the length here. 4 is the length here. And 2 is the length here. So our AC to BC is 6 to 3. And our BE to DE is 4 over 2. And both of these actually will reduce to 2 over 1. Graph triangle MNO with vertices M31, N10, and O30, and triangle PQR with vertices P52, Q, -1, -1, and R, 5, -1. Then write a proportion comparing the rise to the run for each of the similar slope triangles and find the numeric value. So let's go ahead and graph these triangles. We have M, which is at 3, 1. We have N, which is at 1, 0. And O, which is at 3, 0. We have P at 5, 2. Q is at -1, -1. And R is at 5, -1. Let's go ahead and connect the dots, connect our points. And what you'll see is that that line goes through both of our triangles. Let's make those dots a little bit more clear. Those were the ones M, N, and O, and P, Q, and R. Okay, so now they're graphed. It says write a proportion comparing the rise to the run for each of the similar slope triangles. So let's do MO to NO. And PR to QR. And we need to know these distances. So this one is 1. This is 2. This side length is 3. And this length is 6. So MO is 1. NO is 2. PR is 3. And QR is 6. And they both reduce to 1/2. So 1/2 would be our numeric value. And this would be our proportion comparing the rise to the run. The ratio of the rise to the run of two sloped triangles formed by a line is equal to the slope of the line. The ratios of the rise to the run of the two similar sloped triangles in the example in Part 1 are the same as the slope of the line. Since the ratios are equal, the slope m of a line is the same between any two distinct points on a non-vertical line in the coordinate plane. And recall that slope is the change in y, y2 minus y1, over the change in x, or x2 minus x1. So the pitch of a roof refers to the slope of the roof line. Choose 2 points on the roof and find the pitch of the roof shown. Then verify that the pitch is the same by choosing a different set of points. So let's take a look at UT here first. Let's find the slope of UT. So slope of UT. And we are going to use our formula, y2 minus y1 over x2 minus x1. Well, it does not show our points on here, so let's write our coordinates, I should say, on here, so let's write them. T is 0, 2. U is 2, 3. I'm going to go ahead and write S and R as well. S is 8, 6. And R is 12, 8. Okay. I'm just going to use, this is my x1, y1, x2, y2. So it'd be 3 minus 2 are my y values over 2 minus 0, which is 1 over 2. Now let's check this by finding the slope of another 2 points. We'll use S and R, so slope of SR. And I'm just going to say this would be our x1, y1, x2, y2. Our formula is the same, y2 minus y1 over x2 minus x1. We have 8 minus 6 over 12 minus 8. 8 minus 6 is 2. 12 minus 8 is 4. Simplify, and we get 1/2, which is the same as before. So finding the slope is the same thing as finding the rise over the run. Let's do one more. The plans for a teeter-totter are shown below. Using points G and L, find the slope of the teeter-totter, then verify that the slope is the same at a different location by choosing a different set of points. So G and L it wants us to use, so let's write in the coordinates of all these points here. G is 1, 1. H is 4, 2. L is 7, 3. And K is 10, 4. So the first thing we're going to do is find the slope of GL. Formula is y2 minus y1 over x2 minus x1. I'll choose this as my x1, y1, x2, y2. So we have 3 minus 1 over 7 minus 1, which is 2/6, or reduced 1/3. So let's choose any 2 other points. We could do G to K, or H to L, or H to K. Doesn't matter. I'll use H to K. So this one's going to be the slope of HK, y2 minus y1 over x2 minus x1, x1, y1, x2, y2. So we have 4 minus 2 over 10 minus 4, which is 2 over 6, which also reduces to 1/3. So these triangles, or the slopes are different, or excuse me, the slopes are the same at any 2 points, at any 2 different points.